A DNS zone is a collection of DNS resource records, like one that might map itflea.com and its respective IP address. Now, there are two main types of DNS zones, forward and reverse lookup zones. Forward lookup zones are the most common and translate host names to IP addresses. A reverse lookup zone does the exact opposite in that it translates an IP address to a host name. Now, as I just said, a forward lookup zone converts a domain name to an IP address. You can ask a DNS server for the IP address of a host name, let's say ITFDC01, and the DNS server will respond with the IP address of that DNS host name. An example would be typing in the command in command prompt nslookup space ITFDC01. Now this would be an example of a forward lookup. Again, a reverse lookup zone converts an IP address to a host name. So if we ask a DNS server what host name uses the IP address of 10.0.2.10, then the DNS server will query the reverse lookup zone and provide the host name for that IP address. Now both forward and reverse lookup zones can contain primary, secondary, and stub zones. A primary zone is a DNS zone that this DNS server is the primary source of information. Now by default, the data for this zone is located in a file under the Windows directory /system32/DNS. This file may also be stored in Active Directory if this DNS server is also a writable domain controller. Now there's several benefits and reasons why you'd want to store a primary zone in Active Directory. Since the zone is stored in AD, the zone can be replicated using Active Directory's replication process and Active Directory's security features. It's also worth mentioning that a primary zone is the only zone type that can be directly edited or updated. Now, a secondary zone is a read-only replica of a primary DNS zone that is hosted on another remote DNS server. This obviously means that your DNS server must have network access to the remote DNS server in order to gather the information. The DNS zone is not stored in Active Directory because it is a mere read-only copy of a DNS zone. If you try to make a change to a secondary DNS zone, the change request will be passed on to the server which holds the primary DNS zone. If the server is available, the change will be made. The purpose of a secondary DNS zone comes down to redundancy. If the server hosting the primary copy is unavailable, this server will be available for use by clients in its place. Of course, the issues with a secondary DNS zone is that each record held within the zone must be replicated from one server to another. On large networks that have frequent DNS server changes, this can be somewhat resource intensive. Now, a stub zone is similar to a secondary zone in that it is a read-only zone that obtains its information from another remote DNS server. The main difference between a stub zone and a secondary zone is that while a secondary zone contains an exact replica, including all resource records of a primary zone, a stub zone only contains information about authoritative name servers. So inside of a stub zone, you will not find resource records for computer names, but instead records for other DNS servers. The purpose of this zone is to allow hosts on one network to obtain information from a DNS server on another network without this DNS server needing to replicate all of the data inside the other DNS server. You can think of a stub zone as being a less resource-intensive version of a secondary zone. Alright, so now you understand forward and reverse lookup zones. You understand primary, secondary, and stub zones. That's all we need to cover for this lecture. Great job, and I will see you in the next one.